So today we'll cover OSPF. So here is an example, okay, of a routers being connected. So earlier we've seen similar topologies like this, but now all the routers are getting connected to a single area. So this is nothing but this pipe symbol is just nothing but mentioning that it is connected to area 0. Okay. It is not any device, meaning it is a simple network topology representing all these interfaces, right? Gig 01 on all the four routers are connected in this IP range 10.123.4.0/24 range. So that is the logical representation they have mentioned here. Okay. Now,
can you mention it somewhere so that it will be easy for me when I'm reading it?
So what should I mention?
About area 0.
About area 0. No, that's what, so this is clear only, no, this topology?
Like it's not a device or something. It is just there to mention that everything is in single area.
Yeah,
You
that's what this, so this is one kind of network topology I'm telling. So this is one kind of network topology representation showing these two routers in area 0. This is one kind of network topology representing all these four routers in area 0. So that's what I'm trying to say is this is also a kind of a topology where it's only designing, no? The network administrator actually use this kind of symbols or pipe symbols. Okay, a tunnel kind of thing. Connecting the routers means, so this means all four routers connecting to this tunnel, okay? And all these interfaces are connecting, right? To area 0. Okay, that means R1 and R3 is directly connected. Okay, like here, R1, R3 directly connected. R2, R4 directly connected. Got it? It's just in between they have given a tunnel symbol to mention the IP address and the area. So this is also area 0. This is also area 0. This is how the connectivity is. We should able to understand. We should be able to understand that these two routers R2, R4 are interconnected through the WAN interface. R1, R3 are interconnected. This is another kind of representation. Okay. So this is area 0. This is also area 0. There is no connection between R1 and R2. No, there is no connection between R3 and R4. No. Okay. This is another example. Okay. So now what we have to do is we'll see a similar configuration. Okay. How configurations command can be applied for this topology diagram. Okay. So first, 1 second. Config mode, it entered into config mode. And now, first we need to define the router is running on which routing protocol, OSPF. So router EIGRP is the command here, router OSPF, and a process ID, any number. Okay, so router OSPF 1. That means all the four routers are running in the same process or same OSPF process, 111. That should not be changed. Next, again, R1 config Next, after entering into the router, it will actually be something like router -OSPF, I guess. Okay, this will be into. So now you have entered into router OSPF. Here you have to define what are the directly connected networks for this R1 device. Okay, so directly connected networks, what are the IP ranges? 10.123.4, 10.1.1.0. So these are the two networks belongs to this router, and this needs to be advertised to the neighbor routers. Okay, so first I need to advertise my networks, right, in the OSPF of R1. So I'll put the network statement. Okay, 10.120, sorry, 10.123.4.0. Like EIGRP, it also uses the wildcard mask. Okay, so wildcard mask is exactly the reverse of subnet mask. So subnet mask for /24 is 255.255.255.0. Exactly the reverse would be 0.0.0.255 is the wildcard mask. And all these router belongs to area 0. We need to define in the same network statement command the area also. Okay. So from here, we'll directly go to the network statement. Okay. So network, I have another network 10.1.1.0, 0.0.0.255, and that is also belongs to area 0. If at all, if belongs to a different area, we should mention area 1 or area 2, whatever may be, but this network is also belongs to area 01. Okay, now we have completed the configuration for one router, R1. For R2, okay, so for R2, what we are going to do, similar configuration only, but the network statement will be different. So router OSPF 1, same process. Okay, network 10.123.4.0, 0.0.0.255, area 0. Next, network minimize the size. Network 10.2.2.0/24, sorry, 0.0.0.255, area 0. So similarly for R2, R3, we have to configure. So once we have done with this configuration, that means we have enabled OSPF on all the 4 routers along with the area configuration. Without area, I don't think so you will be able to complete the configuration. It should be on area. In some area, if areas and all are not defined, then all the routers should be on the backbone area only. Okay, so once we are done with this configuration, okay, we can just give a command, okay, some similar command like to check, okay, to check how the interface are being configured, okay, can give show IP OSPF interface brief command. This command is also used. Another command is just interface. See, interface or show IP OSPF interface brief is one command. Okay. So with this statement, with this show command, you will be able to see a similar output. Okay. Let me put that in the screen. So show IP OSPF interface. For this, you will be able to see a output kind of thing. Forget about this loopback because that router has a loopback. It will come up here. Else gigabit 0/1 is up. Line protocol is 1. Internet address, whatever address we have assigned for that interface is this. And area 0 has been at the process ID. The process ID is 1, right? We have defined it as 1, OSPF process 1. Router ID is of our choice. So router ID, we have seen, no, what is router ID? So what is router ID? Is a 32-bit ID. It's just going to be used as the representation for that router. Instead of host name, we are going to give one ID, a 32-bit ID for the router. So if we are not defining any router ID, no, by default, the OSPF will take the loopback interface, the highest IP address in the loopback interface as the router ID. Highest IP address. Once again. Okay, so the highest loopback IP address will be taken as router ID. If loopback interfaces are not configured, then the highest physical interface IP will be taken as the router ID. Okay, if we are defining the router ID by the configuration command under OSPF, then that okay, so here I'll just give you an example. After OSPF 1, there's a command, okay? Router-ID. There you need to mention any 32 bit. So it can be 1.1.1 for router 1. For router 2, it can be 2.2.2.2. And router 3, 3.3, any number. So if you define router ID there, you will be able to see it as router ID 1.1. So for all the interfaces, the router ID will be same. 192.168.1. Here also 192.168.1. So this is one simple show command to check if the interfaces are up attached to area 0 correctly configured. Okay. Next is show IP interface brief, right? We've seen another command. Face brief. You will get a brief output. This is a detailed output. This is just a brief output. So interfaces configured. What is the process ID of the router? What is the area? IP address configured, the cost, and what is the state of the router? State of the router. Yesterday we've seen the BDR election process, right? So in that election process, if we are defining any router as DR or BDR, that will also come. Designated router. DR other means it has not participated in the DR or BDR election at all. So it has not participated in that election. So this particular interface or the segment does not have any neighbors. So it is not getting advertised. So this segment is not advertised. So it does not form any neighbor adjacency. So that is the meaning of DR other. Again, this is another output for after configuring to check if the interface or network has been correctly assigned on the interfaces with area configuration. Okay. So another configuration is show IP OSPF neighbor. Okay. So IP OSPF neighbor. Okay. So this actually shows the neighbor. Is the neighbor is being formed or not? Okay, I'll just give you a sample output and explain you. Here, after hitting show IP OSPF neighbor, it is going to actually show the neighbor router's IP segments and interfaces. Okay, it's not its own IP, because earlier output we have seen its own IP segments, directly connected interfaces IP. Now this is neighbor information. Okay, after forming neighbor adjacency. So neighbor ID, this is the router ID. Whatever router ID defined on the neighbor router is that IP for easy representation. Okay, this is, I think this is priority. 1 second. The priority, yes, the priority of the neighbor's interfaces. Okay, which is used for the BDR election, but here we have not configured any election, any BDR to be elected, right? So all the neighbors' priority value will be 1 by default. Okay, next is the state. So state, yesterday we have seen, right? There are 6 to 7 states in OSPF when it starts to initiate or the neighborship to form between two routers. So first it will start with down init, right? You remember? Down init, attempt init communication, like two-way communication, start, exchange, loading, and full.
Yeah,
So
like yesterday class you told, but the definitions, I think they have typed it.
yeah, I've typed it right. Yeah,
Yeah, once if I go through, I'll remember.
yeah. So that state. So for this segment, for this router ID, what is the state? Is it the neighborship is completely formed, or it is just in the process of forming the neighborship? So it is currently, when I hit this command, the output comes right. At that time, the state is two-way. down, attempt init, two-way. So two-way. And what is the router like priority is DR other. This is by default, it will come. Okay, you need not worry about this until unless you manually configure one router as DR and the remaining were on in the BDR state. So you need not, you not, I mean, you need not worry about this output of DR other or BDR or DR for now. Okay, so this is in two-way connection. And dead time. The time left until the router is declared unreachable. That is the dead time. So it started and it is 37 seconds. Okay. So if there is some dead interval being declared, right? If it is going to cross that the timer, then it will be removed from the output, from this output. Okay. And this is the address of the interface of the neighbor. Okay, 4.2, 4.3, 4.4 is the neighbor interface address and its interface name, to which interface it's been connected. See, if there's another router, it has formed a neighborship with another router as well. But that router, the neighborship is full. Adjacency is formed, so it is full. Okay. Again, the timer and all this information. Fine. So if you keep on entering show IP OSPF neighbor, show IP of OSPF neighbor for every 2, 3 or 10 seconds, what happens? Initially 1.1, which comes in two-way, when you hit the same show command, next time it has gone to full. From two-way, it actually crossed many states this in the same sequence and it is full. Full means full neighborship has been established. Okay, that's why the command is being used repeatedly to show the difference. Right? Initially, this 1.1 has not come into the picture at all. Okay, there's no even the hello packet is not sent, so it has not come in the neighbor list at all. But next time, because every time when we establish OSPF for new routers, or it is the first time the network adjacency is going to form, this is how the process will start. After that, you will not be able to see the states changing one by one. That's it. Once neighborship is formed, it is full only. Then even if a new router comes into the picture and you're going to configure, then only you'll be able to see these states. Otherwise, you cannot monitor it. But that too, you should be very quickly need to enter to see the change in the state, no? You should be very quickly entering this show IP OSPF neighbor command repeatedly to see the change in the state. Down, attempt in it, two-way, exchange, extra. Within few seconds, it will actually move on. But very rarely only you'll be able to see. But I'm telling very quickly, you need to use these commands to see there is a change in the state. Okay. So this is about the address. What is this address? The primary address of the OSPF neighbor. So by the command itself is neighbor. So all these information belongs to the neighbor router only, not to its own router. This information belongs to its own router. It's that particular individual's self router. IP, its own interface information. These are all neighbor information. And this interface is nothing but the local interface to which the neighbor router is attached. Okay, this interface is the local interface. That means this is that individual router's its own information, not the neighbor information. Got it? Only this interface alone belongs to R1. Okay, this belongs to R1 router. These information all belongs to neighbor router. Neighbor ID, priority state, that time address and all belongs to the neighbor router. Okay. Next. So now you have configured the OSPF, right? OSPF protocol with all the networks defined. So let's see how the output will come. Okay. I'll just show you another output. Show IP route OSPF. Show IP route. Show IP routing. So this is just a IP routing. What are the routes being learnt on this router? So OSPF, all O stands for OSPF. So this is the router. This is the network learnt via this interface 4.2. Its AD value is 110. Its cost is 2. Okay. So that is the output of, so these many networks are being learnt on this R1 router. So for all these networks, R1 will find a path if it goes via this exit interface 4.2, 4.3, 4.4 or any network. This is the exit interface. And this is the uptime of the neighbor, of this network. Okay, 10.2.2.0 or 10.3.3.4. So this is the uptime of this network being live in the network. So if at all, if this network is flapped or the router connected behind or this IP segment is down and it came up, no, this timer will be automatically changed. So now it is 35 minutes. If it is flapped, it will again reset to 00 and start from there. So there will be a change in the timer value in this column. So at that time, you will know that, okay, there's something wrong with this segment or this router has been recently flapped or went down and came up, and this is the uptime. Okay, by that also we will be able to, because all minor flaps and all, we won't be able to troubleshoot at all. In the real-time network, if a network goes down and it automatically comes up within few seconds, within 30 seconds or 1 minute, for that and all, we will not know what exactly the issue was. We cannot troubleshoot initially because by then the router came up. So we don't have enough time to check why it went down. Is it due to high bandwidth utilization? Okay. Or is it to some power fluctuation? Or is it to some improper cabling? Some loose connectivity in the cabling. So we don't get much time to check if there's a minor flap and all. So even if we report some cases with vendor or service provider saying no, the link was flapped or it was not working for a minute or two, then it came up automatically. Even the vendor also will not be able to conclude the reason why it went down. There is no conclusion. At the same time, if a network is down, okay, say 10.2.2.2 is not reachable and it is down, at that time, if we immediately report to the vendor or service provider or if someone is working on that issue, then they will easily able to isolate the issues actually. Is it a link problem or is it a router problem or is it due to high bandwidth? Okay, if there's some a cable mismatch due to duplex or full duplex or speed duplex mismatch between the both the routers. At that time also, there will be errors in the link. Okay, in the show interface command, just show interface gigabit 0/1. In that command, you will see if there are errors in the link also, the network will not work. It's not related to OSPF routing, but in general with the physical interface, cabling, or high bandwidth utilization on this on that particular office. No, at that time also you will see the network goes down. Okay, I'll just show you one another thing, the cost type. So this is the cost for OSPF. So OSPF uses cost as metric, right? Okay, so interface T1 interface, high speed interface, the cost is 64. For Ethernet, it is 10, fast Ethernet 1 gigabit 1, 10 gigabit 1. So this is the cost defined for each of the interfaces which we are using on the WAN link end. On the LAN, it is anything. LAN, so LAN, what does mean is a router is getting connected to the switch. A router's physical port is getting connected to a switch physical port. So that we call it as LAN interface. A router's physical port connecting to another router. That means that is the WAN port. Okay. So the cost and all are defined on the router's WAN port only, to where it is getting connected to a different router, not on the switch. Okay. Should IP interfaces. So yes, okay. With this, we'll wind up for today for OSPF. Okay. So what we have seen for today is the configuration of the OSPF protocol. How we are going to define the networks in the OSPF. What is the output? Different types of show commands and its output with the explanation. Okay, so these are the basic show commands which you can initially use after OSPF is enabled on the router. You can just use and see what is the show command output, and you can compare it to all the routers connected in the same OSPF process. Yeah, thank you.